Now let's take a look at rational expressions and reducing rational expressions. So a rational expression is any expression that can be put in the form p over q, where p and q are polynomials and q does not equal 0. So for example, 2x plus 3 over x squared minus 6x plus 9 over x squared minus 4, 5 over x squared plus 6, and 2x squared plus 3x over 2. Those are all examples of rational expressions. Sometimes we have restrictions on our variable, and that is when the denominator equals 0, we can say our rational expression is undefined. So here are some examples of that. Let's say I have x plus 2 over x plus 3. Well, I know that I cannot have 0 in the denominator because that makes the rational expression undefined. So what I'm going to do is I'm going to set the denominator equal to 0, so that's x plus 3 equals 0. I'm going to solve that linear equation, and that gives me x equals negative 3. That tells me that I cannot let x equal negative 3, because if x equals negative 3, I'd have negative 3 plus 3, and that would give me 0 in the denominator. So that is a restriction on the variable. Another example would be 5 over x squared minus x minus 6. Well, I'm going to set x squared minus x minus 6 equal to 0. This is a quadratic equation, and to solve quadratics, I know that I need to factor. So I'm going to factor this, and when I factor it, I get x squared minus x minus 6. And if that is equal to 0, then I use my zero product property, and my zero product property says I let x minus 3 equal 0, and I let x plus 2 equal 0. And then I solve each of those. When I solve this, I get x equals 3. When I solve that, I get x equals negative 2. That means inside this rational expression, x cannot equal 3, and x cannot equal negative 2. If I put 3 or negative 2 in there, it would give me 0 for the denominator. So here are the rules to reducing a rational expression. The first is to factor the numerator and denominator completely, and the second step is to divide any factors they have in common. So this might say reduce to lowest terms. Please notice you really need to know how to do factoring to do these types of problems. So I have x squared minus 9 over x squared plus 5x plus 6. So x squared minus 9 is the difference of squares, so that gives me x plus 3 times x minus 3. And I notice that this will factor to be x times x gives me x squared. 3 times 2 multiplies to 6, and if I did outer and inner, that would give me 2x plus 3x would give me 5x. And what I notice is that these will cancel out, so I'm left with x minus 3 over x plus 2. If I were to find the restriction on this, I would say x could not equal negative 2, because negative 2 would give me 0 in the denominator. Let's take a look at another example. So I have 10a plus 20 over 5a squared minus 20. I can factor out a 10 on the top, and I'm left with a plus 2. I can factor out a 5 on the bottom, and I'm left with a squared minus 4. But I'm not finished. I notice this is the difference of squares, so I can continue to factor that to be a plus 2a minus 2. I notice that 5 will go into 10 2 times, so that gives me 2 in the numerator. And I notice that the a plus 2's will cancel out, so that leaves me with a minus 2 in the denominator.